Good evening, welcome to this video for the 2020 Level 2 Algebra paper. So question 1, we're going to factorize 6x squared plus 13x minus 15. So for this question, there's actually a lot of ways we can do this. A very common way is you guess and check with the factors of 6. So for example, you have a bracket of 3x over here and 2x over here and 6x and x. And then you just try to guess the numbers that are up to negative 15 and add to 13. But this way is just guess and check. It could take a while. Another way we could do this is that we can look for two numbers that can multiply to this number multiplied by this number. So let's call this AC equals to 6 times negative 15, which equals to negative 90. So we're looking for two numbers that multiply to negative 90, and we're going to look for two numbers that add to give you 13. So for this one, okay, since it's pretty big numbers, it might take you a while, but you should find that these two numbers are 18 and negative 5, okay? So 18 and negative 5, and we're going to separate out these x terms, and we're going to factor it independently. So we have 6x squared plus 18x minus 5x minus 15. So look, that I haven't actually changed the question since I have 6x squared plus 13x minus 15. Now I have 6x squared plus 18x minus 5x, which still gives me 13x minus 15. Now we're going to factor out this left-hand side and this right-hand side by itself. So on this left-hand side here, we're going to factor out 6x. So if we factorize out 6x, we'll have x plus 3 in the middle. If we see, we take the 6x out, so we have x plus 3, and for the right hand side we'll take out negative 5, and that'll also give us x plus 3. So now we can see we can just combine these two results together since it's both multiplied by x plus 3, which is common. So we have 6x minus 5 multiplied by x plus 3. And that's our final answer for this question, and this is an achieve level question. Well, should be an achieve level question. Question B, a function is defined as f of x equals to x squared plus 10x plus 22. Express f of x in completed square form. So that's x plus of a squared plus b, and a and b are integers. So for this one, for these questions, when you want to do the perfect square form, you're going to be looking at this middle number with one of the x, and you're going to take the half of this number, and that's going to be your bracket. So in this case, we have 10 in the middle here, so 10 over 2 equals to 5. So in this case, we're going to be having x plus 5 squared plus of c. Because as you can see here, x plus 5 squared is going to give us x squared plus 2 times of 5x, which is our 10x here. And then we're going to get plus 25. However, this is only a plus 22. So when we add 25 and we only want 22, we're going to have to subtract 3 away. So therefore, our c value in this case is actually negative 3. So in this case, we can just write this as this equals to everything we had originally, which was x squared plus 10x plus 22. And if we expand this left-hand side here, we'll get x squared plus 10x plus 25 plus of c. As you can see here, our x squared and our x squared terms match, our 10x terms and 10x terms match. However, we have our 25 plus c, which is equal to 22. Okay, so this part here equals to 22. Therefore, c equals to negative 3. And therefore, x plus 5 squared minus 3. So that's our perfect square form. So that's our f of x equals to x plus 5 squared minus 3. And this should be another achieved question here. Okay, question C. In the 16th century, mathematicians were developing a formula to solve any cubic equation. They used expressions in the form of y equals to x cubed minus 12px plus r, where p and r are positive constants. The graph of y equals to x cubed minus 12px plus r for some values of p and r passes through the point A, which is 440, and is sketched below. The question asks us to find an expression for p in terms of r. Since we already have our the cubic passes through the point 440, we can substitute x equals to 4 and y equals to 40, and then that should give us a very clear expression for p in terms of r. So we just write out our formula again. So we have y equals to x cubed minus 12px plus of r, and we know that y equals to 40 when x equals to 4. So 40 equals to 4 cubed minus 12p times of 4 plus of r. So in this case, 40 equals to 4 cubed, which is 64, minus 48p plus of r. Alright, so if we subtract 64 from both sides, we'll get negative 24 equals to negative 48p plus of r. Right, so we want an expression for P in terms of R, so that's P equals to something in relation to R. So we're going to be making we're going to be making P the subject. So in this case, we have we can multiply everything by -1, so we get a positive for our P. So we have 24 equals to 48P plus of R. So therefore 24 minus R equals to 48P, and therefore P equals to 24 minus R over 48. Alright, and that should be our final answer for this question. And this question should be a merit level question since I don't usually do 3 achieved questions in a row, so this should be a merit level question for this question. And in terms of getting achieved, if you can just substitute the point 440 into the equation and get something like this, that could be enough to get you an achieved. Alright, so that's question C. Question D. Question CII. At point B, it is true that 3x squared minus 12p equals 0. Using algebra, show that x equals to -2 p to the power of 0.5, or if you don't like that way of writing it, p to the power of 0.5 equals to square root of p. It's the same thing. Alright, so we need to use algebra to show that x equals to -2p to the power of 0.5 at b. Alright, so they've already given us the equation, so that's 3x squared minus 12p equals to 0. And therefore, if we add 12p to both sides, we'll get 3x squared equals to 12p. And if we divide on 4 on both sides, we'll get x squared equals to 4p. And therefore, if we take the square root on both sides, we'll get x equals to plus or minus 2 square root of p, which is the same as 2p to the power of 0.5. Plus or minus, of course. Okay, so in this case, we're going to be looking geometrically at our point B. It's on the left-hand side of our y-axis, and therefore, because it's on the left-hand side of the y-axis, the x value at point B must be negative. And since the question does tell you that P is a positive constant, so P and R are positive constants, we know P is bigger than 0. Therefore, we know that x has to be negative to root P because it's on the left-hand side of the y-axis. So we can say that, since since P is a positive constant and x is odd, therefore x equals to -2p to the power of 0.5. And that's what was required, and this should be another merit level question. Well, yeah, it just should be a merit level question in my opinion. I'm not, like I said, I don't actually have the marking schedule, so I don't know what the individual grades for each question is. But judging by this question, it is probably a merit level question. And in terms of getting achieved, if you get an achieved, you probably can just get up to here with no justification on why it's on the negative side. You'll get an achieved, probably. Alright, so question III. Consider again the curve of the equation y equals to x cubed minus 12px plus r. As the values of p and r vary, the shape of the curve changes as the length of the orange lines and the central blue line below vary. However, by symmetry, the two orange lines remain the same length as each other. So some examples of the graph obtained by various values of p and r are illustrated below. Alright, so for some combinations of p and r, the curve can intersect the x-axis 3 times. This will happen when each of the orange lines are longer than the blue line. So the orange line is longer than the blue line. That's when our curve is going to intersect the x-axis 3 times. So that's very important information. So find the condition that p and r must satisfy for the graph to have 3 distinct x-intercepts. Write your answer in the form of the exponents of p and r are both positive integers. Alright, so for this question, okay, we're going to be writing down our initial formula again. So that's y equals to x cubed minus 12px plus of r. Okay, so I heard some people were trying to factor this into like 3 brackets, and then you're trying to do a lot of very complicated things, but there's actually really no need since the question actually tells you some very useful information. Since the question tells you that there's going to be 3 distinct intercepts at the x-axis if the orange lines are longer than the blue lines. So all we need is actually equations for the length of the blue line and the equations of the lengths of the orange lines. So if we go back to our diagram here, as you can see, this blue line here, the length of this blue line is actually equal to the value of the cubic at x equals 0. As you can see, the length, this is y equals 0, and this is y of 0 for the cubic. So as you can see here, the length is just when we plug x equals 0 into the equation for our cubic. So if we go back, we will have the length of the blue line. So we'll just write this down. So length of blue line, that is equal to y of 0. And in this case, this equals to 0 cubed minus 12p times of 0 plus of r. And since r is a constant and 0 times anything is 0, this is going to give us a value of r. Therefore, the length of the blue line is actually equal to r. That's what we know. Alright, so now we need to do something very similar with the equation for the orange line, okay? We can choose either point B or C, but I'm going to show you how to do both. So in this case, let's start off with point C, okay? So for point C, we see that the length of this orange line is actually equal to this point here, which we know was r, minus substituting x equals to p, 2 square root of p into the cubic. So that's minus this distance here. So orange line equals to r, which is this whole length here. R is the whole length there. And we're going to take away this portion here, which is equal to y of 2 root of 0.5. So we can say minus y of 2 root p. So that's the length of the orange line on the right hand side. And for the left hand side here for point B, it is going to be the length of this entire black line minus r. So in this case, minus this length here, which is r. So in this case, for point number B, we can say that the length is equal to y of negative 2 root p minus r. Okay, so let's see what those values give us. Okay, so for the length of the orange line, so length of the orange line, we know that y equals to x cubed minus 12px plus of r. Okay, so let's try for point C. So point C, our one was y of 2 root p, and it was r minus. Okay, so that's our length. Right, so y of 2 root p, so that equals to 2 root p to the power of 3 minus 12p times root p plus of r. So in this case, we'll see that this gives us 8, and then root p to the power 3, we can just write that as p to the power 1.5 minus 12p to the power 1.5 plus of r. And we can simplify this since p to the power 1.5 is a like term here, so this equals to negative 4p to the power 1.5 plus of r. Alright, so that's our... Okay, so what we found here, so this is our negative 4p to the power 1.5 plus r. That is the length of this line here. That is the length of the x-axis to point C. Since, therefore, the length of the orange line is just r minus that entire length, okay? So therefore, L equals to r minus negative 4p to the power 1.5 plus of r. So therefore, L equals to r plus 1.5 and then minus r. So the r's cancel out, and our length equals to 4p to the power 1.5. In a similar fashion for the point point B, very similar fashion, we can do the same things. We had length equals to, in that case, it was y of negative 2p minus r. Right, so in this case, we have y equals to x cubed minus 12px plus of r. So y of negative 2 root p, that equals to negative 2 root p to the power 3 minus 12p times of root p, negative 2 root p. Oh, right, negative 2 root p, my bad. Made a slight mistake here. So it's actually 2 root p to the power 3, so that's 8p to the power 1.5 minus 12p to 1.5. That gives us 24 there. Apologize, that gives us 24. So 8 minus 24, that gives us negative 16 there. And negative 16, so that becomes negative 16. And therefore this becomes 16. Okay, I apologize for that. So that's 16 and that's 16. Okay. apologize for that one. Okay, so minus 12 times 2 root p plus of r. So this will give us negative 8 p to the power 1.5 plus 24 p to the power 1.5 plus of r, which gives us 16 p to the power 1.5 plus of r. So that's our y of negative 2 p. And therefore our length is equal to this whole thing minus r, which is 16 p to the power 1.5. As you can see here, these two lengths are the exact same, okay, which is exactly what the question said, that the length of the orange lines on both sides of the cubic are the same. Right, so now the question said that the orange lines are longer than the blue line, okay, so orange lines are longer than the blue line, so therefore 6p to the power 1.5 is greater than r, which was the length of the blue line. And then we need to leave our answer with the exponents of both positive integers. 1.5 isn't a positive integer, but if we square both sides here, this is square both sides, we'll get positive integers as our power. So 16 squared is 256. P to the power of 3 is greater than r squared. And that's our final answer for this question. And this question is definitely an excellent level question. In terms of getting a merit, merit is perhaps you can find the length of the orange line, that's a merit. And if you can find the length of the blue line, that could get you an achieved. Alright, so that was question III. And in terms of the grading, so we only have, at least I've said there's only one excellence question, so either this could be worth 2 excellence points, I'm not too sure, or perhaps one of the previous questions, maybe if you combine 2 parts you might get an excellence, I'm not too sure. But I have no idea on the marking, but this definitely is an excellence level question. And yeah. So question 2, write as a single logarithm in its simplest form. So we have log of 9y plus log 4 minus log 3y. So you know when we add logs of the same base, we can just multiply the inside. So in this case, we have log of 9y times of 4 minus log 3y. And then when we subtract logs of the same base, we can actually just divide the inside. So in this case, we have log of 36y over 3y. And the y's cancel out, so this gives us log of 12. And that's our final answer, and that should just be achieved level question. So solve each of the following equations. Log base x of 36 equals to 2. So in this case, we know that this small x here, that's the base, that's the power, and that's the outcome. Okay, so if you remember BOP, base, outcome, power. And from left-hand side to right-hand side, so we have base, outcome, and power. So BOP, you can remember it that way. So in this case, we can have x squared, therefore equals to 36, and x equals to plus or minus 6. However, x can't be negative 6 since it's a log base. So we can say that since x is a log base, it cannot be negative. Therefore, x equals to 6. Alright, and that should... Okay, so what I'm thinking here is if you can get both of these questions, I'll get you a merit grade. That's my prediction here. So looking at part II, so we have log base 5 of x plus log base 5 of 2x equals to 4. As we were saying in question A, when we add logs of the same base, it's the same as saying we multiply the inside since it's both log base 5. So therefore we can say this is log base 5 of 2x squared equals to 4. Alright, and now we can just carry out our BOP rule. So we can just say 5 to the power of 4 equals to 2x squared. 625 equals to 2x squared. And okay, so we divide both sides by 2. So we have 312. Okay, we don't like decimals. We'll put in a fraction. So 625 over 2 equals to x squared. Therefore, okay, so x squared equals to, sorry, x equals the square root of everything. So square root of 625 over 2. Square root of 625. So that's 25 over root 2. Right, so getting both of these questions actually get you a merit level grade, okay? And getting just one of them should just be achieved. Alright, so question C, solve the equation 5x plus 4 over x plus 4 minus 3x minus 4 over 2x plus 1 equals to 2. Alright, so in this case, we're going to be making the same denominator, so we can add and subtract the numerators. So we're going to cross multiply, so we have 5x plus 4 multiplied by 2x plus 1 over x plus 4 times of 2x plus 1 minus 3x minus 4 times of x plus 4 all over x plus 4 times of 2x plus 1. That equals to 2. Alright, so now we're going to be expanding our brackets. We're going to have, on our left-hand side here, we're going to have 10x squared. So be very careful here. So 5x, that's 4. 5x. So we add 5x, add 8x, so that's add 13x plus of 4 times 1 all over. We'll just leave the bottom hand here just in brackets for now. So minus this whole right hand side, we have 3x times x, that's 3x squared, plus of 3x times 4, so plus 12x, minus 4x, so that's plus 8x, plus negative 4 times 4, which is negative 16, all over x plus 4 times 2x plus 1, that equals to 2. Alright, so now we're going to subtract the numerators. So we have 10x squared plus 13x plus 4 minus 3x squared minus 8x. And double negative makes a positive, so plus 16 all over x plus 4 times 2x plus 1, which equals to 2. Alright, so if we further simplify this, we'll get 7x squared plus 5x, and 4 plus, so plus 20 divided by x plus 4 of 2x plus 1 equals to 2. And we're going to multiply both sides by the denominator. So we have 7x squared plus 5x plus 20 equals to 2 times of x plus 4, 2x plus 1. Alright, so we're going to expand this right-hand side here. So we have 2 times of 2x squared plus x plus 8x, so plus 9x plus of 4 times 1. And that's 7x squared plus 5x plus 20. Alright, so if we expand out on the right-hand side here, we have 4x squared plus 18x plus 8, and 7x squared plus 5x plus 20. Alright, so now we're going to subtract the like terms on both sides and make equal to 0. So 3x squared minus 13x plus 12 equals to 0. Alright, now we just need to solve this polynomial. We should get x equals to 3, or x equals to 4 over 3. What I'm getting, so let me just double check this one. Okay, so it's always a good idea to plug these numbers after you finish your question. You plug these numbers back into your denominator first, and you see if any of them make equal to 0. If you make it equal to 0, you know the denominator can't be equal to 0 because you cannot divide by 0, so that's invalid. So if we put x equals to 3, nothing wrong, and we put x equals to 4 over 3, so there's nothing wrong. So both these solutions could be valid, and let me just verify one of these solutions. So just try to make sure I got this right. 4 plus 3 minus 3 minus 3 sorry, 3 times 4 plus 4. Yeah, okay, so that's correct answers there. Okay, so this question could be an excellence level question. Okay, it could be an excellence or a merit level question. I'm not sure. It could be could be an excellence level question, but also could be a merit level question. So, yeah. Question D, consider two parabolas. Parabola 1 is given by y equals to x squared plus bx plus c. Parabola 2 is given by y equals to dx squared plus dx plus c. All of these are constants. So use algebra to determine the restrictions on the value of a, b, c, d, and e that would ensure that the parabolas meet at two distinct points. Okay, so for this equation, we need to make the two parabolas equal to each other since they meet at particular points. So we're going to say ax squared plus bx plus c equals to dx squared plus ex plus c. The c's already cancel out, so we can just get rid of that. So now we can move everything to one side and make equal to 0. So x squared minus dx squared plus bx minus ex equals to 0. And now we can factor in the like terms. So we have x squared and x squared here. So we can say a minus d x squared plus b minus ex equals to 0. And we can actually factor out x here, if you can see. So x can be factored out, and we have a minus d times of x plus of b minus e. And that equals to 0. So therefore, we know that either x equals to 0, that's one of our solutions, so that's number 1, x equals to 0, or we have this whole thing equals to 0, which is a minus d x plus b minus e equals to 0. So therefore, a minus d times of x equals to e minus b. If we move it to the other side, it becomes negative, so x equals to e minus b over a minus d. And that's our number 2, so that's our second solution. Alright, so for two distinct points, so the first thing we need to make sure is that the denominator doesn't equal to 0. If the denominator equals to 0, this solution obviously will not exist. So therefore, a cannot be equal to d. Okay, a is not equal to d. And second of all, we need to look out for repeating solutions. So we know that x equals to 0, so that means number 2 can't be equal to 0. Since if both of these solutions equal to 0, then they're actually only touching at one distinct point, which is x equals to 0. So therefore, this whole thing cannot be equal to 0. And therefore, we know that e minus b cannot be equal to 0. So therefore, e cannot be equal to b. So that's our restrictions. And you know that there's no restrictions on c since they're both the same. They've both been shifted up or down by the exact same unit. It doesn't matter, okay, since these two c's are the same. So we can say that no restrictions on c. Right, so those are our restrictions. So x equals to 0 will always be a point where they intersect. And another point that intersect is just x equals to e minus b over a minus d. And we know a can't be equal to d, since that's going to give us a denominator of 0. And we also know that e can't be equal to b, since that's going to give us a repeating root. And that's really all we need for this question. And that's should be an excellent level question. Alright, so question 3. Solve the equation 3 to the power 4x equals to 30. So we can take the logs on both sides with 4x. Sorry, using the pen again. Okay, so 4x log of 3 equals to log of 30. So therefore, 4x equals to log of 30 over log of 3. So therefore, x equals to 0.774. That's our final answer there. Question B, consider, that's achieved. That's an achieved for sure. Okay, so consider the function w equals to x plus 2 to the power of 2 over 5, and x is a whole number. So that's very important. So x is a whole number. So make x the subject of the formula w equals to x plus 2 to the power of 2 over 5. So first we've got to get rid of this to the power of 2 over 5, so we can chuck that to the other side and make it the reciprocal, so 5 over 2. So in this case, we have w to the power of 5 over 2 equals to x plus 2, and therefore x equals to w to the power of 5 over 2 minus 2. And that's it for that question. And for question part 2, for what values of x will the function have values less than 20? So we're going to say that w is less than 20. So therefore, x plus 2 to the power of 2 over 5 is less than 20. And if we just move this power of 2 to 5 to the other side, it will become 2 to the power of 5 over 2. Reciprocal, so x plus 2 is less than 20 to the power of 5 over 2. So therefore, x is less than 20 to the power of 5 over 2 minus 2. So therefore, x is less than 1786.85. Alright, and that should be that final answer for those questions. And these two combined should be a merit, and just one should be an achieved. Okay, so apologize for that. Forgot to check this. Okay. Okay, so Zara sells zips. So Zara notices that the higher the price of a zip, the fewer zips are sold. So that's some economics there. As an experiment, Zara increases the price of a zip by $2 each day, starting at $7, and keeps a record of how many zips are sold each day. She does this for 6 days and finds that the number of zips sold each day started at 98 and is dropping by 3 every day. The total amount of money Zara received each day for tips, the turnover, is also recorded in the table below. If all the patterns continue to be valid, is there any day on which the turnover is exactly $445? Use algebra to justify your answer and explain your conclusions. Alright, so first things first, we know that the turnover is the total price of a zip multiplied of how many things she sells. Okay, so basically money earned equals to price of one thing times how many of these things are sold. So we know that the price of a zip is given as 2D plus 5, and the number of zips is 101 minus 3D. So our turnover T, we'll call it T, equals to 101 minus 3D multiplied by 2D plus a 5. So turnover equals to negative 6D squared plus 202D minus 15D plus 505. So this equals to negative 6D plus 187D plus 505. Alright, so we want to make this equal to $445 to see if any day that Zara sells zips can be giving a turnover of $445. So turnover equals to 445. So 60 squared plus 187D plus 505 equals to 445. So if we subtract 445 on both sides, we will get 60 plus 60 equals to 0. I'm going to just solve this using a graphics calculator since it's the easiest way. Okay, so we have negative 6, 187, and 60. Alright, so we should see that our D value is 31.48 and or D equals to negative 0.318. Alright, so first things first, obviously the number of days cannot be negative. Okay, so obviously, so clearly D is not negative. So D is not equal to that negative value. However, for D equals to 31.48, we need to note that Zara is selling zips on a whole number of days. Okay, she's selling zips on a whole number of days. And that means that every day, so for example, for this first day, she's selling zips at this price and she sells an X amount of zips. So there's not really an in-between, like she can't really say that during half the day the number of zips is gradually decreasing. No, it's just that for one whole day the price is set and the number of zips is set, and for the next day a different price and a different number of zips is made. So there's not really any in-between, so there's only D equals to an integer. So basically, since at a set price every day, and so since Zara sells zips at a set price every day and sells a different number every day, sorry, I cannot spell. Okay, so a different number every day, hence D is a whole number. So therefore, we can say that there's no day. So therefore, no. So first we say D cannot be equal to this. And so therefore, we say that there's no possible ways that Zara can make a turnover of $445. So $445 turnover, not possible. And that could very well, if you give the correct reasoning and justification, that could very well be an excellence level question. It could very well be. But on the other hand, it could also just be a merit level question. So I'm just going to put the bracket R. It could be either merit or excellence, like a borderline. I'm not too sure. But definitely, if you have the correct justification and you're talking about why it can't be 31.48, you're giving the correct reasons, then it could be very well be an excellence level question. Okay, it's not entirely impossible. Alright, so for part B, I forgot to rub out this again. Sorry. I forgot to apologize for that. Alright, so this was a pretty tricky question. Okay, I'm not gonna lie. Okay, this question was pretty weird, but it's okay. We'll try to work through it. So Zara realizes that not every whole number is a possible turnover value for a given day. Using algebra, find at least 3 conditions for a whole number k that must satisfy for it to be a possible turnover for a given day. Alright, so first we're going to write over our equation for our turnover, which was 60 squared plus 187d plus 505. And we're going to call our turnover k. Okay, so therefore k equals to negative 60 squared plus 187d plus 505. So therefore, if we subtract k on both sides, we'll get this. Okay, so that's what we'll get if we subtract k on both sides. And now we're going to be, first of all, we're going to look at our discriminant. So our discriminant equals to b squared minus 4ac. So that is 187 squared minus 4 times of negative 6 times of 505 minus k. That's our discriminant. 187 squared, that gives something. That gives discriminant equals to 34969. So 4 times negative 6 times 505, that's a negative, but we have the negative on the outside, it becomes positive, or 4 times of 6 times of 505. 4 times negative 6 times negative k is positive 24k, but we have the negative, which makes it negative again, so 24k there. So if we simplify this a little bit, we should get this bad boy. So it's 47,089 minus 24k. Alright, so first of all, in order for this whole thing to even exist, we need to have a turnover that is obviously making the discriminant greater than 0, okay? Either equal to or greater than 0, okay? So it can't be less than 0, so that's not going to give us any real solution. So that's the first thing. So 47089 minus 24k, that's obviously greater than 0. So therefore, Alright, so therefore k is less than 1,962. And we also know that k must be greater than 0 since Zara isn't making a negative turnover. That would be pretty concerning if she was, but we know that Zara isn't making a negative turnover, so it's between these two boundaries. So that's k is in between 1962 and 0. Right, so the second part of this, we're going to be looking at it in a more deep level. So we're going to be pulling out our quadratic formula. So that's our d equals to negative b plus or minus square root of b squared minus 4ac all over 2a. And we're going to write it out. So d equals to, we know b is negative 187 plus or minus square root of, we know the discriminant is this, all over 2a, which is negative 12. So d equals to 187 over 12 plus this discriminant, I'll just put discriminant all over 12. Alright, so we know that in order for some turnover to exist, it needs to happen on an integer day. Okay, that's what we discussed in the previous question. Since Zara is setting her price at the start of the day and making an X amount of sales every day, and she's doing that every day, she's not changing the price during the day. That means that anything that happens is just in a whole number of days. So therefore, we know that d is an integer. D is an integer. So d is an integer. So now we're looking at this formula, so that's plus or minus, so 187 over 12 plus or minus discriminant over 12. Okay, so in this case, we're going to be looking at what can yield a whole number for d. So first of all, we know that 187 over 12, that is not a whole number. That is like some random number. That is like 15.58 something. So obviously that is not a whole number there. So obviously we need a discriminant here to make this a whole number. Okay, so since this is plus or minus, so first we can consider the minus side, okay? So the minus side, the closest way we can make this an integer is 180, if you notice. 180 over 12, that is going to give us 15. That's going to be d equals to 15, okay? So that's d equals to 15. That's the closest one we can get. So therefore, our discriminant over 12, so that equals to 7 over 12. So discriminant equals to 7. And notice that for each multiple of 12 we go down, that's a possible day. So we can say that discriminant is 7, and we can keep going 12, 12, 12. So 7, 19, 36, etc. So the next one would be, not 36, I can't math. Okay, so 7 plus 12 is 19, plus 12 is 31, 31, that's our next one. Then we have 42, and then it just keeps going until our d is negative. So since we can't have a d negative value, so it's going to keep going down until we get to the point of, when do we get to, okay, so 187. Sorry, so just apologize. Okay, so 187. So Okay, I actually can't do math. That's not even 40. That's 43. Apologize. Okay, I'm not mathing. Okay, so 7, 19, 31, 43, and that's gonna keep going until we get to 187. Okay, that's gonna keep going until we get to 187. That's gonna stop. Okay, so that's our first set of solutions. Since we can't go over 187, it's gonna give us a negative number. So that's no good. So second is when we adding, if we start to add the discriminant, that's going to give us a new set of possible days. So that's going to be our closest one, so 187 plus something over 12, so 187 plus 5. So 5 is our closest one. Okay, so we have plus 5, plus 17, 29, 41. And if I'm adding this correctly, we have 53, and we just keep going. And this one also has a dead end. Okay, this dead end is actually reached when we get to a point where day exceeds 31 point, I think, something. No, day exceeds 33. And the reason for this is if we go back to our zips here, we know that the number of zips is 101 minus 3d. So let's just say d equals to 33. So if d equals to 33, we're selling 2 zips. And on the 34th day, we're going to be selling -1 zips. And obviously, it's not really, theoretically, in a real life situation, it's not possible to be selling a negative number of zips. So therefore, that's not possible. So therefore, d is restricted to 33. So that's where it must end, okay? And if we do 33 times 12, that gives us 396. So it's going to be keep going until we get to about 209. It's going to stop, okay? That's going to be our limit. So again, if our discriminant can be equal to any of these numbers that satisfy this series, so this series we can give an equation of 12n minus 5, so that's number 1. So it satisfies this, or it can satisfy this one, which is also 12n, which this one would be minus 7, okay? So just try 2 times. Yeah. So if it can satisfy any of these equations, then it was going to be a valid zip, okay? And that's really the best I could come up with in terms of this question. It was a very challenging question. It's obviously an excellent level question, very challenging question. But that's it for this paper. And it was a challenging paper, but I hope you enjoyed, and I'll see you all in the next video.